Good afternoon, everyone. I'm Craig Huber. I'm a DevOps engineer at Capital One. I work in our Toronto software studio where I set up infrastructure in the cloud and help our development teams deploy their applications using Docker. We have a number of applications in production running on Docker, and we're increasing that number every day.
Hey guys, my name is Jirui. Ooh, that's too loud. I'm a test engineer at Capital One. At Canada Software Studio, we do a lot of automation for all our applications as part of CI/CD pipelines. For writing browser-specific testing, myself and some other test engineers have been using Selenium WebDriver. Since this year, we have been working with our DevOps engineers to see how Docker can enhance our browser test infrastructure. This is where this topic came from. And since there's no similar topics, we hope this will be an interesting and fun session for you guys.
So a couple of months ago, we looked into browser testing using Docker. Today, we'll talk about what we learned during that time and what other options are available in the market. Also, where Docker fits into the picture and some of the lessons that we learned along the way setting up Selenium Grid with Docker. And hopefully, when you walk away from this talk, you'll know how to set it up using Docker and some of the tips and tricks that we learned.
I should stand away. Before I jump into the options for remote browser testing, let me give you guys some background on Selenium WebDriver, the tool we use to automate our browser testing, and also a set of issues that I have faced when I start to automate our tests that eventually led me to think about remote browser platform. So first, Selenium WebDriver is an open source tool for browser testing. It provides a set of drivers to control your local browsers. It also has a set of APIs to specify browser actions. For example, it can control open or close browsers. It can also click buttons on a page or enter user credentials in the login form or wait for some element in the page to show up. WebDriver APIs support most popular programming languages, so any developers or testers can easily pick up and start automating tests. Now, here are the issues that I have experienced when I start to automate browser tests. First one, and the worst one is, browser test is slow. How slow? This slow. So even with automation, a medium to large scale testing project can take hours to finish. Now, I really don't want to end up like this guy, so I need to reduce my testing time by start thinking about parallel testing. The second issue is our developers in team want fast feedback on their code commits. This requires automation tests to be part of the build process. But I cannot run a real browser in headless build server. So that's when remote browser platform came into picture. And last, business always wants applications to support multiple browsers or multiple versions, which means I cannot avoid cross-browser testing. So to tackle all these issues, I need a remote browser platform. It has to support multiple browsers, as well as parallel testing. So with all these requirements, I started to explore my options. The first one and the easiest is always to find something in the market. And yes, I found a SaaS provider with a mature remote browser platform. There's no infrastructure setup required on my side. I can simply point the test to that platform and it automatically executes against browsers on that platform. This remote browser platform supports most popular browsers and their versions. And it has very nice features to troubleshoot tests during execution. But after I've used for a while, I've discovered some downsides too. For example, our company, like most others, use VPN to access corporate network. It took me some time to set up VPN connection between this remote browser platform and our corporate network. And even after that, I've discovered the network connection between those two was slow. So the overall testing execution time was much longer than I expected. So this doesn't really solve the slow issue. And on top of that, for a monthly subscription, it would cost me more if I want to start parallel testing. Eventually, I realized that this is an optimal solution for me. So I turn away and start looking for something else. Now, for those of you who knows Selenium WebDriver, you may also know my next option, which is Selenium Grid. At that time, I was about to roll my sleeves and build my own grid, like the guy in the picture. But I didn't, mostly because I don't have an awesome server room like he does. No, that's not it. But I do turn away from this option. Before I tell you guys why, let me give you guys some introduction on Selenium Grid. In a traditional grid setup, you have a set of Java processes called nodes. Each is hosted on a physical or virtual machine. All these nodes register to a single process called hub, with the browser information that are installed on the same node machine. So once all these nodes are registered, the grid setup is complete. Now I can point my UI tests to the hub machine. So when the tests run, they are automatically dispatched to one or more node machines, where browsers are created and execute them. I could have built a small grid, and it would work nicely for a while. But my worry is, it could get messy if I want to scale them up for supporting additional browsers or start heavy parallel testing. I would have to buy more and more machines or creating more virtual images. And I also need to manage all these machines and connectivity of the entire grid. That can be non-trivial work on a daily basis. And too bad. Other teams cannot really easily replicate my setup without going through the entire process again. Thanks. So finally, I stopped this path. And after I explored both options, I felt myself at a dead end. To be honest, I was sad for several days. But all hope was not lost. That's when I discovered there are Docker images for Selenium Grid. Now, let me pass to Craig, who will show you how Docker saved the day.
Thanks. So using Docker and Selenium Grid, we were able to greatly simplify our entire setup. We now have the ability to scale on demand. We have much better performance and easier management compared to the options that Chiri just discussed. And on top of that, we can control our costs because we're running in the cloud. So what does this all look like? We still have the hub and the node, but this time now they're running in Docker. We have different browser versions running in their own containers. And we could have set this up all on one machine, but we have several Docker servers for added performance. And since we're running in the cloud, we scale up based on CPU load. So new servers are added to the swarm automatically. To get the hub and the nodes to communicate across Docker servers, we added we enabled swarm mode. So the added benefit of running in swarm mode is that we can scale the different browser versions up and down as we like. So side note is we use Terraform to build all our cloud infrastructure and Ansible to orchestrate it all. So Selenium provides a couple of Docker images on Docker Hub. There's one for Chrome, Firefox, and PhantomJS. And they're all actively updated with the different versions, browser versions and Selenium versions. They're all roughly about 700 megabytes. They're pretty easy to pull down and share. And in our case, we've customized these and pushed them up to our own internal Docker registry. So the great thing about these images is that if you want to build, for instance, a different version of Chrome or Firefox, you can just use a build arg and pass in the version that you'd like to have a different version. And likewise, you can customize these at runtime. So in our case, we're adding in environment variables for Java options and controlling the max heap size. And we also add in other environment variables to control the grid specifically. So you no longer have to mess with different VM images. It's much easier using Docker. So that's all awesome. You might ask, how do you set this up? Initially, we made the mistake of using bash scripts just to get up and running quickly. So you want to start using Compose. And so first, we created an overlay network using Compose so that the different containers could talk to each other across Docker servers. And next, we added a service for the hub. We're using image tags to specify the version of Selenium that we want. And we're adding it to the same overlay network called Grid. We're also exposing a port that we can connect to the browser and see the status of our grid running. Next, we added services for Chrome. And we're adding it to the same overlay network called Grid. And we're adding only one replica at this point. I should also note that we've customized our own images heavily and have our own different versions for different browsers. So next thing, we'll also do the same for Firefox. It also has similar options, but with only one replica and also on the same grid network. Now we place some constraints when we run these so that they only run on the Docker workers instead of the Docker managers, since the tests can become pretty CPU intensive. So now we want to deploy it and run it against our Selenium grid, Docker Swarm. So using the Docker stack deploy command, we can deploy what we have in our Compose file to a stack called Selenium. So if I run Docker stack deploy, within a few seconds we'll have a node up and running. So if we run Docker service ls, we should see a node and a hub and two nodes running, one for Chrome and one for Firefox. So this is all well and good, but now we want to be able to scale it. So at this point, we only have single concurrency. With one Chrome and one Firefox version running, we're only able to run one execution, one test at a time per browser. So if we want to scale it up, we run the Docker service scale command, and here we're saying we want 10 Chrome replicas. So if we run Docker service ls again, you'll see we have 10 Chrome 55 containers running. And here's what I was talking about earlier. We have different services for Chrome, for different versions of Chrome and different versions of Firefox. And so if we point our browser to the Selenium hub, this is what shows the status of our grid. And you'll see we have different versions of, or 10 versions of Chrome 55 running. So it's all like magic. It's all like magic. But what we found really cool was that if you're running in debug mode, which there's an image available for, it actually has a built-in VNC server and a built-in X11 server. So if you're trying to debug some unexpected test results, you can connect using VNC to the container and see the browser running live. So in this screenshot, this is a VNC client connected to a running container, and normally you'd have some tests running. So this all sounds great in practice, but in reality, it wasn't it's quite as easy as it sounds. So there's a few things that you probably want to know before you jump in. First, there's no image for Internet Explorer or Safari. So if you're planning to use those versions, you're out of luck. Second, getting the hub and the node to communicate across Docker The Docker servers was a little bit tricky at first. We just had to pass in some environment variables so that they would know how to communicate with each other. But once you've solved that, it's pretty smooth sailing. Sometimes the nodes become unresponsive after a test runs. So this is easily solved just by starting and stopping the container. Also, we found that passing in some environment variables for the Selenium hub to control the timeout sessions helped a lot. So what does this all give you? We no longer have to wait for a VM to start up or long session creation times or complicated VPN setup like we had with our SaaS provider. We found that our tests run 2 to 3 times faster, and if we want to run those even faster, we can just add more servers to our swarm to increase our capacity. With Docker Compose, the great thing is that we can share our Compose file and run the same setup on our laptop or with another team that wants to build their own grid. And since we're running in the cloud, we only pay by the minute. So as opposed to a SaaS provider that charges a flat monthly fee, we shut down all our instances at night, and we don't get charged for what we're not using at night. So we hope that you're able to take these learnings away and build your own grid on Docker. Thanks very much.